This is my custom design setup for testing the Infineon TLE94112EL Motor Shield driver for Arduino. The motor I use here is a Mabuchi FD180PH19125/42DV, as you can see in the video. This is a brushed 6-volt DC motor. I believe it's excess pieces for a shaver or something. It's rated at 6 volts with a 0.07 amp rating and a stall rating of 1.95 amps, and it has a approximate speed of 7,900 RPM. You'll note that each motor is marked with a red dot for the positive terminal and the opposing negative terminal. No EMC filtering capacitors were used because I was under the impression that the shield took care of any EMC interference. I soldered the appropriate leads, then put pins on the ends, heat shrunk tubing to keep things kind of neat, and then place each motor in my 3D printed custom designed 6-motor holder designed specifically for that Arduino example that was provided by Infineon. I then printed a disc with the 3D printer that could be attached to the top of each motor, labeled them, and the motors range 1 through 6, starting from the left-hand side is motor 1, and each one has the appropriate number of rings to represent them as well. And then you can see them attached to the shield, the Arduino, and one of the power supplies I use. You'll note that when I connected the motors to the shield, I connected each positive lead from each motor to an odd numbered output to maintain the integrity of the polarity. Here are some sample runs at different voltages to demonstrate the erratic behavior, and I've posted some of the serial monitor printouts as well. Here we start with 6 volts. Notice that the motor 1 spins for a bit and that's it, and then everything goes dead. Now I switch to 5.8 volts and it appears as though everything works fine, but then the erratic movements start again and it doesn't correspond to the programming. Remember now that according to the Infineon Arduino example sketch, motors 1 through 6 are activated for 1 second, then braked for 300 milliseconds, and activated in the reverse section for 1 second, and then braked for 300 milliseconds. And then the PWM function is activated for motor 1. At least that's what's supposed to happen. Okay, now you can see I'm repeating the process at 5.6 volts, and then we take it down to 5.4 volts. Again, things don't work quite right, and for informational purposes, what you can't see is I have a switch off to the side so that each time I run this test, I first shut off the USB to the Arduino and make sure the power is shut off, and then I turn the Arduino on, let it boot for a few seconds, and then turn the power on. Now we're down to 5.0 volts, which is far below the 5.5 minimum rating for the voltage supply for the shield, and yet it appears as though the motors are probably operating fairly close to the best that they have so far. Then finally, to demonstrate the upper and lower ranges of the operating rates that I'm getting with this, I run tests at 4.8 and at 6.1 volts, which show total failure. Nothing really turns. There's a little bit of start-stop if you watch twitching that occurs, and that's it. I'm posting once again at the end of this some of the serial monitor reports if you're interested.